Kia ora everyone, we're up to the very lucky lastly but not leastly question here. Question 5 of part 9 of our Python challenge questions. And let's take a look at it first. We're writing a program to solve the general quadratic equation. For those of you that haven't come across this quadratic equation, this is for solving equations that fit that form ax plus bx plus c equals 0, right? These can be notoriously hard to solve. Normally in maths class, you try a whole lot of guessing and checking, particularly if you're doing algebra, just starting out algebra. You work through some numbers in your head, you see if some multiples fit, but there's actually a formula for finding these. And it's called the quadratic equation, and it is there. And we don't make the math as programmers, we just implement it, right? So our job, and for you mathematicians out there, is to implement this formula and find some solutions to the quadratic equations up there, right? Now, this is not possible for all combinations of A, B, and C. There are some combinations that don't work, but there's many that do. I've got some that do work. They're just random numbers I picked up, made sure that they did actually work. But what are we actually solving here? Let's talk about that first. For those of you familiar with maths class, you might be given a graph that looks a little bit like this, with a y coordinate over here and an x coordinate over here. And there might be a quadratic on this graph for whatever reason. Maybe you're doing something with some forces, or maybe there's some gravity involved, and maybe this is flipped over. And what you want to do is you want to find the points, when I get back into focus, the points on the x coordinate where x is 0. You want to find that point, and you want to find that point there. Now there are two of them. There's two of them most of the time. Sometimes there's only one when it just touches. We're going to assume that there's two of them for the moment. And maybe you can make your program a little bit more general to accept the cases where there is only one as well. Sometimes there is none. Sometimes there are no solutions. And we're going to include in our program a way to check if there are no solutions, or if there's, maybe we can add in a way to check if there's only one as well. Okay, cool. So there's our equation there. X is equal to negative b plus minus. Ooh, that's interesting. Plus minus. That's not a symbol that we have in Python. That's not even really a symbol we have in mathematics, really. What's that doing? It's saying there are two solutions to this equation. There is one we use the plus symbol. There's one we use the minus symbol. And then we're taking the root of b squared over 4ac minus 4ac, and that all of that is over 2a. Okay, do we have to understand why that is the case? No, we just have to implement it. Let's take a look. Okay, I have on here a, b, and c already in. We're just going to work with what we call literals. I've literally put the number in there. Rather than getting input from the user, we will make our program do that soon. Oh, okay, so x is going to be equal to, now let's implement this formula. I wish I could pull it up and we could sort of see it and refer to it, but instead we're going to be doing a lot of flicking back and forth. Negative b plus, we're going to deal with the plus case first. Negative b plus square root. Now, square root function. We can't take square roots in vanilla Python. That square root function doesn't live in the normal library. It lives in the math library. And unless I go and pull it out, I don't have access to that yet. So let's go and grab that. How do we grab the function? How do we grab that function when it lives in another library? I say from math import sqrt. I now have access to that function. I could have imported the whole math library and said math.square root. The syntax is a little bit longer, and I'm not using anything else from the math library. So it's good practice to only grab what you need, unless you're going to need lots and you're not sure what you're going to need from the start. Only grab in what you need. Makes it a little bit clearer. Negative b plus the square root of what? B squared minus 4ac. B, double asterisk, 2 for squared, minus 4 times a times c. And yes, you do have to put all of those in there. Cool. All of that over 2 times a. Is that going to work? No, it is not. Why is it not going to work? Because bednass. I need to take that whole thing there and make sure that that is what is divided by 2a, not just this part here. All right? Okay, so that's going to give me one of the solutions. Let's print x. Let's see if it works. Hey, look at that, a solution. Does it mean anything to us? No, not really. But it is solved. It is solved. One of those points has been found. Let's find the other one. How do we do that? Well, it's the case where we added that square root. So copy that. Let's call it x2. And let's say negative. Print x and x2. There we go. I have both solutions. So one's quite positive, one's a little bit negative, but we've found both places where x is equal to 0. Wonderful. Okay, what are we going to do now? We are going to take some input. Are these going to be floats? I don't think so for the moment. I think they're going to be integers. So I'm going to print up the start. I'm going to print welcome to the quadratic solver. Given the form a squared plus a times x squared plus b times x plus c and print what is Let's take that, let's copy that a couple of times, A, B, and C. Okay. Whoops, get my syntax right. What is A? Let's give it a little bit more space here. Make it look nice for the user. A is going to equal 10. B is going to equal 6. C is going to equal 32. Oh no! No solutions found. What can we do here? What can we do in order to say that there are solutions or there are no solutions? Well, we can use something, I'm not sure if we've used this before, but it's very, very useful. We can say try, and we can try to solve this, and just by tabbing that in, First thing Python is going to do is it's going to try to solve these equations. Now you see over in my error over here, it said math domain error. That means something has gone wrong in the math. It's probably there are no solutions to this. Well, certainly there are no solutions to this. So it's tried to solve it and it hasn't been able to. So math domain error. And then what do we do after try? We put the word except. So if there is an exception, it's going to come up and it's going to say, if there's an exception, it's going to run the code that we put in under here. In fact, we want this line in our try. And if it raises an exception to this, we're going to say print no solutions. And cool. What is A? A is going to be 1. B is going to be 1. C is going to be 0. Solutions are 0 and -1. Is that correct? That is correct, but I want A to be 1, I want B to be 0, and I want C to be 0. Solutions are 0, 0, and 0, 0. Okay, so this is a classic example of where there is only one solution, but it's found that solution twice. So rather than printing both, let's just put a little if statement in here and go if x equals x2. Let's go print. Let's just print 1. Let's say, in fact, let's say one solution. And then we're going to print x. And here, we're going to have a little else statement. Two solutions. X and x2. A is going to be 1, B is going to be 0, C is going to be 0. One solution where x and x is 0, 0, 0. That's working. We now have a quadratic solver. You could use that. You could use that for your maths homework. Why not? There's the whole code. Actually, the tricky part was actually just getting the maths and the symbols right here. And there is that try except thing that I don't think we've seen before. Should we try just to see if the except is working? We know that try is working when there is a solution, and if there's one solution or if there's two solutions. What about if there's no solutions? Let's just run something with no solutions. A good way to do that is to give really positive numbers and make sure that it is not crossing that X line. No solutions. There we go. So it tried to solve it. It couldn't solve it, so it raised an exception, and the code knew what to do when we raised an exception. It just printed no solutions. That's it. That's it finished. I am going to do another video. I'm going to show you what you can do now that you have completed those all of these in the series. I think that's it for us. There are some other ones, some Te Reo numbers to do, and there's a lyric exercise, which is a bit of fun. But the main core part of these is done, so well done for getting this far. I'm going to do another video just showing you where to from here, some other things that you can do, some other places you can go to practice and to sharpen up on your Python. And apart from that, I will see you next time.